Hello everyone, welcome back to my channel codeWithKhan. I hope you are doing very well. Let's see today's LeetCode problem, which is 1382 balanced binary search tree. Okay, so what is binary search tree? For each node from its left we will have the values less than the root value, and in its right we will have the values greater than the root value. That is known as binary search tree. So it is marked as medium. Let's read the question. Given the root of a binary search tree, return a balanced binary search tree with the same node values. If there is no more than one answer, return any of them, right? If there is more than one answer, if we have more than one answer, we can return any of them. And a binary search tree is a balanced if the depth of two subtrees of every node never differs more than 1. Okay, so we already solved yesterday's problem of by balancing the binary tree. So right, its left subtree difference and right subtree difference should be less than or equals to 1. It should not be more than 1. Okay, now let's read the constraints. The constraints are the number of nodes in the tree can be in range 10 to the power of 4. So we can easily go with n square solutions also, but it's will go for the optimal solutions only. And note that nodes values can be less than or equals to 10 to the power of 5, and we are not doing any product or summation of the values, so we are good with this. Now let's take one example, right? So they have given to us this binary search tree, right? 1 2 3 4. Okay, so any binary search tree, right? So if we do the what we'll do is we need to generate this type of balanced subtrees, right? So balanced binary search trees. So this is unbalanced, right? Why? Its left subtree's height is 0 and its right subtree's height is, for example, 1 2 3, right? 3 minus 0 is greater than 1, which is 3 greater than 1. So it is not balanced binary search tree. But here if you see, its left subtree height is 1 and its right subtree height is 2. 2 minus 1, which is 1, is less than or equals to, right? Less than or equals to 1. So it is balanced. Here also same. Its left subtree height is 2 and right subtree height is 1. So it is also balanced binary search tree. So we need to convert them into either into this form or this form. So we can return any of the subtree. Okay. Now if we observe in binary search tree, so what we'll do is, so any binary search tree, if we do the Inorder traversal, we will get a sorted array, right? If we do Inorder traversal, let's do the Inorder traversal for this binary search tree, right? What is the Inorder traversal? First we will go to left and then we will read the node, root node, and then we will go to right. So do we have anything left to it? No, we don't have. So we'll read the root node, which is 1, then we will go to its right, and when we reach the node we will go to try to go left. Do we have anything? No, we don't have. So we'll read the root node, which is 2, and then we will go to right, and when we reach any node we will try to go to left as much as possible. We don't have anything in the left, so we'll read the root node, which is 3, and then we try to go to the another node, and do we have anything to left to it? No, we don't have anything. So we'll read the root node, which is 4, and then we'll go to right. We don't have anything. So Inorder traversal will be completed. So what we have got in Inorder traversal, we got a sorted array. What we got? We got a sorted array. So key observation is, so whenever we do a Inorder traversal on a binary search tree, we will get a sorted array. Okay, now what we'll do is we will build a binary search tree, a balanced binary search tree using these node values simply. So how we will build using this binary search tree is, we will pick the middle element, right? We will pick any middle element, right? Either we'll pick this one or we'll pick this one. So as per our finding the mid logic, we will use finding the mid logic, right? Which is left plus right minus left by 2. So we'll use this logic to find the mid, right? In any binary search, we'll use this same logic to find the mid, right? We'll find a mid, and its left part will become a left subtree, and its right part will become right subtree. So its height is maintained, right? If you pick in, if you divide an array into half, right, we'll have equal number of values, right? If it is even, like either we will choose a middle element as a root, and its left part will have same elements, and right part will also have the same number of elements. So using this logic, we will pick any element as a root, and its left part we will build it as a left subtree, and its right part we will build it as a right subtree. Okay, so what we'll do is, now let's take, once we have created this array, right, 1 comma 2 comma 3 comma 4, 2 3 4, what we'll do is, we'll call a method like build bst. We'll pass these values, right, 0 comma 3, right. What we'll do is, first we'll try to find the mid value, right? We'll try to find the mid value. So at the first time we'll have 0 comma 3, right? What we'll do, we'll try to find the mid. So mid will become 0 3 plus 3 minus 0 by 2, which is 0 plus 3 by 2, which will become 0 plus 1, right? Which will be 1. So mid become 1. So our mid value is 1. So what we'll do, we'll create a root node with this mid value. What is the 1's value is 2. So we'll create a root node with the 2. So we have created a root node. So what we'll do is, we need to build its left subtree, and we have to build its right subtree. So what we'll do is, we will traverse, we'll create, so if you observe, this is become another subarray, and this became another subarray. What we'll do is, we'll call the same method, right? We'll recurse it, and we will build its left subtree. From left value is 0, and we'll pass mid minus 1. What is our mid? Which is 1. 1 minus 1, which is 0. So we'll call it on 0 comma 0, right? So now we came to the its left, so we got 0 comma 0, and we will see what is its mid. 0 plus 0 minus 0 by 2, which is 0 plus 0, which is 0. So mid value is 0. So what we'll do, we'll create a node of 0th index. So it will be 1. So we have created one node. Now what we'll do, we'll try to build if there are any subtree to 1. So if you'll see, clearly observe here, we have mid as 0. What we'll do, we'll try to go left, which is 0, and mid minus 1 is 0 minus 1, which is minus 1. So we are here, we are going index out of bounds. Minus 1 is not in the range. So what we'll do, we'll simply return null. So it will be have null here. Okay, now we'll go to right again. So right will be mid plus 1 comma its right. Its right is 0, and mid is what? Mid is 0. 0 plus 1 comma 0. 1 plus 0. So whenever its left is greater than right, so what we'll do, we'll simply return null here also. So we'll return null here also. It will have null here also. So now it's, if we observe, its left subtree is completed, right? So if we observe, its left subtree completed. So we'll return from here, and we'll return from here also. Now what we'll do is, we'll try to build right subtree here. So now here what is the mid element? Mid element is 1. So while going right, we need to pass mid plus 1. What is 1 plus 1, which is 2, comma right is 3. So we have 2 comma 3. Now what is the mid element of 2 comma 3? 2 plus, let's take right, which is 2 plus 3 minus 2 by 2, which is 1 by 2 is 0, and 2. 2 plus 0 is 2. So mid element is here, mid is 2. We will create a node of index 2, which will be 3. Now we need to build left subtree for this 3 and right subtree for this 3. So for left subtree, what will be the range? It's left and mid minus 1. What is mid? Mid minus 1 is 2. 2 minus 1 is 1. So it will become 2 comma 1. Here left is greater than right, so it is this is our base condition. Base condition is left should not be greater than right. This is our base condition in any binary search also, right? So that means our binary search, so we don't have any left thing to create. So what we'll do is, here in this case this condition is true, so what we'll do, we'll return simply null here. So now we'll try to check for right. So what is the right? Mid plus 1, which is 2 plus 1, which will be 3, and right is 3. Is 3 is greater than 3? False. We'll move further and we'll try to find the mid element for this one. What is the mid? Mid will become 3 plus 3 minus 3 by 2. 0 by 2 will become 0, which is 3. So 3 plus 0 is 3. So mid element here is 3. So what we'll do? We'll try to create 3 element. So we'll create element 3 and we'll try to find if any elements left to create in its left subtree and any elements there to create its right subtree. So what we'll do, we'll try to go left, which is left is 3 and its mid is also 3, right? And mid minus 1 is 2. Here also condition is left is greater than right, so we'll return simply null. It will have null value. And its right also, what is right? Mid plus 1. Mid plus 1 is 3 plus 1, which is 4, and its right value is 3. So what will return? Here also left is greater than right, so we'll return null. So if you observe, we have clearly created a binary search tree with root as true. The left subtree's height is 1 and its right subtree's height is 1, 2. And its difference is 2 minus 1 is 1, which is less than or equals to 1. So it is balanced binary search tree. Okay. Now what is the time complexity? Let's say time complexity is we have traversed each node at once, so it will be order of 1. So we have created the array with Inorder traversal, and we have created a BST, and each node will be visited once, so it will be order of n. And space complexity is we have created an array with n elements, so it will also be order of n. Okay, now let's code for it. Okay, so what we'll do is, to store the variables like the node values, we'll take a list, a class level variable, list of integers, let's call it as nums. Okay, now let's initialize nums is equals to with array list. Okay, the first thing we need to do is we need to do Inorder traversal. We'll call Inorder traversal method with this root. Now let's write Inorder traversals. Let's implement this method. So it's public void Inorder traversal of tree node root, right? What is the base condition? Base condition is if root is double equals to null, we'll simply return. That's it. It's void method. What we'll do is, Inorder traversal means we need to first traverse the root dot left as much as possible, and then we will add root dot value, right? And then we do Inorder traversal for the root dot right. That's it. So this is for Inorder traversal. If we do this, it will have nums will collect all the node values in sorted order. Now what we'll do is we'll build the binary search tree using this nums list. What we'll do, we'll write another method builds BST. So what we'll do is it will take values left and right, which is nums dot size minus 1, and we'll find the mid and we'll create a node and we'll build the left subtree and right subtree recursively. So what we'll do is now we'll create this method as well, will BST, and it will return public tree node build BST. It will take into left and in right. So what we'll do, First we'll find the mid, which is left plus right minus left by 2. So what we need to do if we found the mid, we need to create new node, root new tree node with this mid is the index. So to access, get the value from the nums, we'll get the value. So once we have that, what we need to do, we need to build root dot left subtree, which is, we will call the same build bst recursively. What we'll pass the left to, since we are building the left subtree, what we need to pass mid minus 1 here, and then we will build the its right subtree, right will equal to, we'll call build bst recursively here also, and here what we'll pass mid plus 1 and right value. So once it is done, what will return, we'll simply return the root value. So what is the base condition for this recursion? Base condition is if our left is greater than the right, then we'll simply return null. That's it. Now let's run this code. Okay, something wrong, which is nums no n. Now let's run this again. Okay, we are missing the return statement, so we are calling the build bst, we need to return this same, it will return the root element. So let's run this again. Yeah, it is accepted. Let's submit it. Yes, the solution is accepted, guys. If you like my content, please do like, share and subscribe. Thank you very much for watching. Bye.